Okay, welcome to 2.2. This is going to be in 3 parts, I believe. So just bear with us, bear with me. We'll be looking at solving inequalities by adding or subtracting, and basically what we want to know, or what our objective is, how you can use properties to justify solutions to inequalities that involve addition and subtraction. Again, how to use the properties to justify solutions to inequalities that include addition and subtraction. So basically we'll be working backwards to isolate our variables to solve our inequalities. That's going to be the purpose of this video. Part 1, we'll look at the different properties of the inequalities, with the purpose being to know why we do certain things or how we can justify what happens in our inequalities. Okay, so we're going to scroll up right now. Oh, I'm sorry, looking at the wrong thing. I'm so sorry, gentlemen. That is not okay. Okay, so looking at the wrong thing. Just scroll up. Here we go. Okay, so we have 2 properties right here. The addition property of inequality, and what this means is that if A is greater than B, then A plus C is greater than B plus C. So if A was 1 and B was half and C was 2, well, 1 plus 2 is going to be greater than half plus 2. That's all that's saying, okay? And then that also says that if A is less than B, then A plus C is going to be less than B plus C, okay? The subtraction property of inequality, very similar. If A is greater than B, then A minus C is greater than B minus C. And if A is less than B, then A minus C is less than B minus C, okay? We're not talking about... We're not talking about these inequalities yet, greater than or less than. Those definitely will apply here. Those just were not incorporated in here, but they still count, okay? So you could just as easily say that if A is greater than or equal to B, then A plus C is greater than or equal to B plus C. Same thing, okay? Now let's look at number 1. How do the addition and subtraction properties of inequality compare to the addition and subtraction properties of equality? Okay, so again, we're looking at inequalities versus equalities. What's the difference between the two? Well, the addition and subtraction properties of inequality are similar to both of those properties for equality. They're very similar. In fact, they're almost exactly the same, except that one is dealing with inequalities and the other one is dealing with equals. So they are the same thing, okay? The main difference is that they have inequality symbols instead of equal signs, and because they have inequality symbols versus equal signs, that each property is stated twice, because you could have an instance where you have greater than, or you could have an instance where it's less than. So all this means is that essentially they're the same, with the main difference being the symbols that are used, and that the properties for inequality are a little bit longer because they have to contain information for scenarios where we have greater than, or when we have, less than or greater than. And that's all that is saying. Okay? You can pause it if you need to, but let's continue. And I keep trying to scroll on my video. All right, so most linear equations have infinitely many solutions. That means that as you're writing the answers could go on forever. And we don't want you to have to write all the answers forever, because that would be the rest of your life. You'd be answering this one question. So when using set notation is going to make your life easier. What it's going to do is that it's going to list all of the solutions in brackets or in braces, okay? So the solution x is less than or equal to 1 in set notation is for all quantities of x is less than or equal to 1. And then you close it in the brackets, in the braces. This is how you read it. The set of all x such that x is less than or equal to 1. That's the way you would say that. Okay? And here's what it looks like. This is the set of x, okay? all x. So everything in here is a set. We're including all of x. This line means such that. And then this tells you x is greater than or equal, less than or equal to 1. Pretty simple stuff. A number line. A number line graph can be used to represent the solution of the linear equality, and here's how you would do it. To represent less than or equal to, mark the endpoint with an empty circle. Okay, in this one, x is greater than 1, so we would draw a circle and then draw the line, because x is any number greater than 1. To represent less than or equal to or greater than or equal to, mark the endpoint with a solid circle. That means that includes that number. So if x is greater than or equal to 1, it would be a solid circle, boom, just like that. That means x is greater than 1, and it also could equal 1 or greater. All right, shade the part of the line that contains the solution set. So for x is less than 1, it would be everything here. And then for x is less than or equal to 1, it would be everything here. And on this one, don't forget that open circle above the 1. Okay, so this is greater than, this is less than, simple stuff.